Yeah, it's critically important when you're prototyping that you can knock one off really quickly to have a look. It's really difficult to physically know if something's going to fit or it works, or whether it works within its parameters when you're looking at something in the computer. So when you actually take it out and physically put it in the real world, you go, oh, well of course it's not going to fit around there, or it goes around there, or hit this thing that whatever. So from that point of view, if you really wanted high-end stuff, I could now take this off to one of the high-end manufacturers that have high-end machines and get them printed really, really nicely. But I don't need to. But you can do. If I was a designer that had projects that needed to be produced in a slightly better manner than this, there's lots of other different forms of 3D printing, and some are a lot more expensive than others. And this is the most cheap and viable one. Architects are using it. Fashion designers are using it. There's a lot of medical applications that are coming through. There's people that are printing enzymes and what have you. I didn't bring it with me actually. I've got a trial of a new filament which is made with wood powder, so it's basically a printing with MDF and smells like burning plywood. So the fact is that most of these other things, oh, you're getting a block of plastic and cutting out a block of plastic, that's subtractive manufacturing. We're talking about additive manufacturing. So there's no waste product from your, if you were building a thin thing like this, we don't have to take the in and the out to produce it. We can produce it from the ground up in a very thin. If we wanted to just see what it looked like, we don't have to put a mass inside it. So we just have a hollow thing to see what it looks like. Or if we need it solid, we can make it solid. I've got totally full control over how many layers that has, how many deep it is, if I wanted to fill it, put a lid on it.
So how would you know about the failure of a file and a design? Would it tell you beforehand? Does it do a rerun?
Yes, it will. It will. The slicer at the moment will tell you if something's got a hole in it, or if it can't do it, or if it's not sitting like 0, or what have you. It will tell you that. And then you can take it into MeshLab, another free bit of software, for piddling about the meshes and fixing them and slicing them and editing them.
Because presumably if you had...
The tool chain's all a bit fragmented at the moment, because it is new and it is open source. So there's lots of other versions of this stuff that I use. This one's running on printer interface, Frontiface. This is run by another RepRap group from, I think they started in Germany, these guys, but it's a worldwide thing. People have added to it and made it better. And this is doing exactly the same thing as that, but this has got a really nice 3D visualization with it. But at the moment, the code from this won't work with that. So there's lots of stuff that won't work with this, but it works with that, or this works slightly better with this. So there's lots to learn about it. But to keep it basic, if you've got a printer that's dialed in and working, you can download a model from Thingiverse that's all ready to go and go print, and it'll go straight away and do it.
Can you adapt things from Thingiverse?
Yes, you can. Yeah.
So
a lot of people will build stuff in, say, OpenSCAD, and they'll give you the OpenSCAD file as well.
Right.
So you can actually rebuild the model or see how the model's built.
So that's a free...
Or you can edit or work around various parameters of the mesh itself. It's better to fiddle around with the model itself.
Yeah.
If someone's built it in Google SketchUp,